I think that many of you have heard or have some knowledge of such term as zero trust, also known as zero trust networks or zero trust network success. Even though the concept cannot be referred to as really new or cutting edge, in any case, it is quite surprising that if you ask several experts, what does zero trust mean? If you ask them to tell you at least approximately how this concept is fundamentally different from the earlier ones, you will get a set of quite different answers. And if you ask them to describe the principles, components, and even the logical architecture in more detail, you either won't hear anything sensible at all, or the answers might even contradict one another. My name is Artyom Sinitsyn, I am the head of information security at Microsoft in Central and Eastern Europe, and soon enough we will figure out together what zero trust is, that is to say, a zero trust concept or model actually means, what it is, what it is not, what historical conditions led to the emergence of this concept and in fact defined it as such. Then we will analyze the principles on which this model is built, its logical elements, the relationship between them, and we will see how Microsoft has practically implemented this model internally. And finally, we will see how you can start your own journey towards the implementation of the zero trust model. However, we will start with the background. I believe that most of you remember those wonderful times when we had a network perimeter. Creating such a network perimeter in an enterprise was like finding a holy grail of that time. It included setting up an array of cluster of several border routers, creating a so-called sandwich between two border firewalls, organizing DMZ, also known as demilitarized zone, and beloved by everyone. The main distinguishing feature of this approach was that we do not trust things that are outside of the perimeter, but at the same time, by default, we trust everything that is inside. Over the time, this concept revealed issues that were quite critical for the functioning of an enterprise in terms of security. Today, of course, the situation looks quite differently. Now, people work generally outside of the corporate network. Access to data and data processing is also carried out outside the corporate network. There are a lot of places, channels and points of connection, a huge number of different form factors and devices to which we connect, different types of applications that we use to access information. At the same time, the very network of interaction within one enterprise or its business activities has greatly expanded due to the growing number of new counterparties, partners, subcontractors, and so on. The level of business globalization, in general, has also increased over time. Now, why is this important? Because it means that the traditional paradigm, which implies the creation of a network security perimeter and trust by default to all assets and access subjects that are inside this perimeter, has generally lost its relevance. Now, let's try to figure out why it has happened. Before now, most of people worked in the office. The concept of a laptop, or even more so a mobile device in general, wasn't so popular yet, and even if there were, the percentage of employees who used them or connected remotely in the enterprise was minimum. Most likely, these were employees of the IT department who had sufficient skills. Now we are faced with the fact that technology has become popular with the general population. Almost anyone, including grannies and grandpas, can use advanced technology, but for us, the information security specialists, this trend has actually resulted in many problems. I have already said that, in general, the entire landscape of information technology has changed, and it has become more complex. And now, as a result, our objective, that is to say, protecting information assets that we're obliged to protect, Because, well, let's not deceive ourselves, the objective of information security specialists is quite simple. We have to provide access to information to those who should have access to it and restrict access to those who should not have such access. Everything is very simple. Let's not make it look more complicated than it is. However, nowadays, this task becomes more complicated or often even impossible to achieve. Why? Because most of the assets, such as removed mobile devices and laptops, leave the network perimeter of the enterprise and move to some kind of external storage, including clouds. At the same time, hackers, who are not fools, over time clearly realized that instead of trying to hack each of the protection levels of the network perimeter, they can switch their focus from the network level to the application level, or to the level of what we call digital identities. And if they compromise the account of a specific employee, they can impersonate this employee and thus cut through all the security controls located in the network perimeter like a knife through butter. That is why, over the past few years, phishing attacks have become amongst the most popular attacks and cyber threats, and account credentials have become the new digital currency for attackers. It is bought and sold. It is sold by thousands, tens of thousands, in bulk, and so on. And that is the reason why such attacks as password spraying and credential stuffing, among others, are so popular. In general, today, we will not dwell on this in great detail. I think that you know all about it. Summing up the historical consistency of the traditional paradigm of network perimeters, I cannot say that the firewall is dead. We definitely still build our security systems based on the firewall. But if earlier the creation of a network perimeter was necessary and sufficient, now, in my opinion, it remains necessary but is no longer efficient. Accordingly, new challenges require new creative solutions. How do these solutions look in the modern world? Let's analyze the evolution of the so-called security perimeter step by step. Initially, as I believe everyone knows, there was a network perimeter. We built fences around offices, put bars in data centers, locks, provided physical safety and security. Then a digital perimeter was created. So it was already something digital. We have already talked about it in sufficient detail. It involves the creation of some kind of network security perimeter, dividing it into various zones with different levels of trust in case of some kind of advanced implementation, including several time zones, some quarantine zones, and dynamic resource allocation between all these zones. But now, even this is not enough. In order to cover the modern landscape of potential attack points, we need to expand the concept of the perimeter and build a so-called identity-based perimeter, meaning a perimeter that is not based on some kind of network location or dynamic location, but dynamically moving along with the movement of the access subjects who have certain identifiers, identification data. That is, this is why it is called identity-based perimeter. It is clear that when attempting to hack through standard network channels, or with the use of some standard attack patterns, the attacker will be stopped at the network perimeter. But in case of attacks aimed at compromising account data, if such attacks are successful, an attacker will impersonate a legitimate user and, using his or her credentials, will gain access to the network perimeter. This is the first point to consider. We have already talked about this shift from the point of view of attackers. The second point is that we get additional, so to speak, the geographical scope of information assets that we must protect is widening. It has to do with mobile devices, portable devices, the ubiquitous use of cloud services and cloud applications. Even if your company banned cloud applications, most likely they are still being used, because the most important thing for users, well, actually there are several things: habits, convenience, availability, and so on. Generally speaking, the use of unauthorized cloud applications in the workplace is called shadow IT, with which traditional network perimeter has no chance of coping. What can work in this situation? A perimeter based on account data. Regardless of whether information assets are moving, on what device they are located, in what cloud storage, we have an access subject and an access object, and the access subject has a certain identifier, identification data, identity. If we build our security perimeter based on these data, it becomes absolutely unimportant to us where the information assets themselves are moving. We will control access at the time of access request or during an already established working session when the user is accessing data. In general, which of the modern concepts allows, among other things, to implement this approach while constructing a dynamically increasing, dynamically movable identity-based perimeter? This is precisely the concept of zero trust. Before we move on to talk about the concept of zero trust, in part we have already started to talk about it, I would like to touch upon the misconceptions around the concept of zero trust. I have compiled here a list of the most common misconceptions I have encountered in my practice, and it is very important to deal with all misunderstandings immediately, so that later you will not have any false ideas through which you will be trying to understand the concept. In the first place, the concept of zero trust does not imply a complete lack of trust or not trust in anyone. This is not true. Moreover, if you are trying to create a system in which you will not have trust in any subject, in the vast majority of cases, well, most likely you will not be able to do this. Information systems cannot be built without trust in principle. Even if they are built like that, they will not function. The main thing that a business needs is having access to data, no matter how much you would like to restrict it. Secondly, zero trust is not a product of any particular manufacturer or supplier. I have even seen in some marketing documentation the phrase as zero trust as a service. Now we have everything as a service: software as a service, infrastructure as a service, desktop as a service, etc. In general, all this has to do with the dominance of certain models of cloud resources. So zero trust as a service is complete nonsense. There is no way it can be done, and if you see such offers, I recommend that you should be very cautious with them. Thirdly, zero trust as a model implies the creation of a modern perimeter that is built on identity data. But the concept is not solely built around the creation of a next-gen perimeter. We used to have next-gen firewalls, etc. Zero trust is much more than just a new branch of security perimeter development. Fourth, it often happens that people talk about zero trust as just a new modern approach to creating virtual private networks or next-gen VPN. This is not at all true. Moreover, zero trust at its mature stages, after the implementation of some of the steps, implies that VPN should be altogether given up, because VPN actually implies a fairly wide attack area, which is very difficult to control and to reduce. Fifth, zero trust is also called the killer of the corporate network or an intranet segment. This is also not the case, however. The implementation of the zero trust model may lead to complete disappearance of intranet from your system, but it is not always necessary. And lastly, zero trust is not some specific, time-bound project that has a finishing point. It is not just one project, rather it is a strategy, a way of thinking, a set of principles and paradigms that guide you when creating the security architecture of your organization. Now, let's talk about what zero trust actually means. And for this, I'll give you a background of this model development. By the way, we will even see that, in fact, this concept is not entirely new. People call it the new paradigm in cybersecurity, but in fact, it isn't really new. Zero trust exists or at least its history dates back to 2004. In 2004, there was a significant event when all the key players in the security market gathered together. As far as I know, people from San Francisco companies claim that they organized the so-called Jericho Forum. At that time, certain trends were recorded there, namely that the concept of the network perimeter is losing its relevance, it is quickly becoming less effective, and we need a new approach. At that time, there was no such term as zero trust, but people coined the term deperimetrization, which is directly related to the emergence of the zero trust model. Also, in the second half of 2000s, many security vendors with a focus on network security began to supply such solutions as network access control, network admission control, etc. So these services meant that at the moment of connecting a certain device to the infrastructure, to the network, a number of checks were performed related to the health of the device in order to identify if this device can be trusted, and only after successfully passing these checks defined by the network access control policy, the device could gain access to the network. I think that people who were involved in security at the time have encountered this technology. The issue with this technology was that it was very vendor-dependent, and it turned out that it was very difficult to adapt and scale this approach in order to meet the demands of the industry in 2010 and beyond. As far as I remember, according to the legend, in 2009, a Forrester employee for the first time sealed the right to be the person who invented and introduced the concept of zero trust in the industry. In fact, zero trust was then a logical continuation of the process of deperimetrization. That is, rejection of the network perimeter as a fairly effective and cornerstone security concept. And zero trust is what you should aim for. Better to say even that it is not the thing to aim for, but how you should move on. Then, somewhere in the mid-2010s, we saw separated approaches. In fact, some of the players in the market have chosen to focus on the implementation of the concept at the network level. Mainly, these were manufacturers of network security solutions. It is understandable because they know this market very well, and it is logical that they should develop this concept, or rather practically implement it from this perspective. Another camp consists of companies that have tried and are still trying to implement the concept from a perspective on identification data, identifiers as security subjects. This is a much more ephemeral structure. Many companies, including Microsoft, work in this field to this day. And then, sometime in 2014, Google presented its Beyond Corp concept to the world. This was one of the first practical implementations of the Zero Trust model. I recommend you to learn more about it. Technically, it is quite exciting. The only problem was that it wasn't replicated much outside of Google. That is to say, Google made it for itself, and everything turned out well and smoothly. And so far, this model has every right to exist, but at the same time, it is quite difficult to replicate it for some smaller company that Google, or a company with a different infrastructure, with a different set of controls and security technologies. At least I haven't heard of any other successful implementation. Let's continue. Meanwhile, Microsoft, using the identity approach to the model implementation, in 2016 released the so-called conditional access, or access with extended dynamic condition. We will talk about it today more. Nowadays, Zero Trust architecture is documented by the US National Institute of Standards and Technology, NIST. I believe it is known to all information security experts. In 2019, NIST released a paper that describes the architecture of the Zero Trust model in great detail. If I'm not mistaken, an update was released in March this year. I haven't read it completely. It's a multi-page document. There are hundreds of pages. And if you really want to dive very, very deeply into this issue, you definitely need to read this document. It is a completely vendor-free and highly recommended study material. The last point that I wanted to highlight point here is that people might obviously ask, why not compete with each other? It would seem that there is some kind of dispute or some kind of competition between two camps, two approaches. However, while the approaches are conceptually different, it would be best for a company to use both. But at the moment, as far as I know, there is no example of successful implementation with the introduction of these two branches simultaneously. The so-called process of convergence of these two branches hasn't been yet practically implemented. But in any case, everything points towards this in the future. You need to take the best of the both worlds and adapt it to your needs and business processes. Now, I will quickly explain to you what is Zero Trust model based on precisely the NIST document. Zero Trust is, in fact, a set of constantly evolving paradigms in the field of cybersecurity, which doesn't focus on trust based on where the subject or object of access is at any given moment. Instead, the focus is shifted to users, to the devices which they use, the applications through which they gain access to data and the information, assets that they access. A very important point is that, by design, no subject and no device from which the user connects has any level of trust. This is what the term zero trust refers to. That is, by default, we have zero trust. This does not mean that we do not trust. It means that we trust but check constantly. It means that in order to gain access, it is necessary to prove that any given user of the device can be trusted. Only then will this user gain access in accordance with the level of risk and with the level of trust that he or she is allowed to at the moment. Let's continue by talking directly about the architecture. We will start with the principles that are probably the most fundamental and high level at the same time. The three principles for building a zero trust model are as follows. First of all, it is trust no one, check constantly, or trust but always check. This principle can be understood from the definition itself. It means that it does not matter where the subject of access is, regardless of whether she is inside the corporate network, in a wired or wireless segment, on the internet via VPN or not. To be able to understand it more easily, you just need to remember that in the zero trust model, all users and all devices are on the internet. This is the easiest way to remember it. That is, just imagine there is no intranet. The vast majority of all users work by always connecting to the internet, which you do not trust in any way. The second principle on which the zero trust model is based is the principle of the least privilege level, which of course is as old as the world. But here we're talking about its more modern reincarnation, so to speak. It is a dynamic role model. Just-in-time and just-enough administration, JIT and GIA. For those who are not familiar with these terms, just-in-time means getting elevated privileges only when necessary, after going through a special approval procedure with an audit, login, etc. And GIA is its brother concept, so to speak. GIA means providing only the minimum required set of operations which can be performed by a specific subject within a specific session. I think that probably the most well-known example is that we have a domain controller and we have a DNS server on this domain. Most often, the role of the DNS server and domain controller are both on the same node. As soon as you give someone the opportunity to make changes to the DNS, you give him or her elevated administrative rights to control the domain, and accordingly any administrator becomes a domain administrator. If this is the root forest, then the forest administrator. Accordingly, in the standard paradigm of providing access, it seems to be impossible to protect the system from the administrator in the DNS. In fact, it is possible by using GIA. You can make for the administrator a separate connection point with a specific set of command-led PowerShell and parameters that they can execute within a specific zone and create a specific record type in this zone. The third principle is to constantly assume breach. Probably it is best reflected by a quote from a former FBI director who said that there are two types of companies, those who have been hacked and those who do not know yet that they have been hacked. In general, this is probably the perfect example. I will say it a little differently. The question is not whether the company will be hacked or not. The question is when it happens. And the most important question is to what extent the company will be ready for this. What and when it will do, how quickly it will be able to detect attempts to hack and spread within the network, how quickly it will be able to localize the actions of an intruder, malicious applications and malicious code, and how quickly the response team can cleanse the infection from the company's infrastructure and restore the normal functioning of information systems. So we have analyzed the principles on which the Zero Trust model is built. Now let's see what parts this model consists of. Let's talk about its logical components. Obviously, for maximum efficiency, the Zero Trust model should cover the entire digital landscape and include all types of identity data, or put it simpler, identity. All types of identities, including user IDs, device IDs, service and application IDs. Identity should also include the devices themselves in any form factors, working on all modern platforms, including IoT devices. Various applications should also be covered, including legacy applications and modern applications that support these standards, such as OAuth, OpenID, Connect, SAML, and FIDO2, which support cutting-edge passwordless authentication. Further, these are, of course, infrastructure elements, network resources. What can we do without them? This also includes segmentation, priority allocation, and micro-segmentation. And, of course, last but not least, there are the data themselves, digital assets, protection of access to which is our main objective. Now, with the components explained, let's figure out how to connect it all together. In general, those connectors that allow this model to be so graceful, for the lack of a better word, consist of three parts. The first part is signals. The more types of different signals we have, the more realistic assessments of the real picture we can get, and thus we will be able to better calculate the risks associated with a specific access request, a specific transaction or operation with an information access. It means that the efficiency of the security system directly depends on the signals. Moreover, the signals may obviously be quite diverse: location, network address, country of connection, device type, user account, group membership, role in the organization, having a place in the current organizational structure. Basically, it can be anything at all. Anything you can imagine. Anything you can get from inertial systems, any number of attributes. The more signals there are, the more efficiently we work with them, the more efficient the implementation of our Zero Trust model will be. The second part is the decision. The effectiveness of the decision directly depends on the signals that we have just discussed. Here, there are two very important aspects. First of all, any decision must comply with the security policy approved at the company. A very important element of the effective implementation of the Zero Trust model is a predetermined, sufficiently flexible and adaptive, and probably even dynamically evolving, changing security policy. These are those basic sets of ideas that we will have to comply with in any case. And the second aspect is that decisions should not be based on signals, and most importantly, they should not be static. It means that a user cannot get a reserve of trust for a long period of time as before. For example, a user upon connecting proved his or her identity, passed the authentication procedure successfully, providing only his or her password, being the only attribute. And at the time, it was enough. Now it is not enough at all. And even after successfully passing all the checks necessary for the connection and the start of a working session for this particular user, the decision may be dynamically changed during the working session itself. It means that if something changes, even after working with the data, our implemented model, trust, firstly, need to disconnect, re-execute the dynamic risk assessment procedures associated with the current transaction and the subject of access, and make an adequate decision, which may be completely different from the previous one. If earlier it provided access, now the access may be denied. And then, during the working process, the user will be disconnected from the system. And the third part is enforcement. Basically, this is a kind of a mix of all security controls which are enforcing compliance with the security policy adopted in this particular organization. In general, these are role models, authentication policies, differentiation of access according to the level of the confidentiality of the document, differentiation of access based on the category of an information assets, etc. This is the enforcement unit that implements our decision with regard to access to information assets. Now we have finished discussing the principles and pillars, so-called Lego bricks, from which we will build our system and connecting components that will help us to establish interaction between all these elements. Let's now take a look at the whole picture. In essence, this is the conceptual architecture of a typical zero-trust model. So you can see now on the slide that at the center core, at the heart of this model is the so-called security policy engine. The input of this engine is a parameterized security policy adopted in the organization. In fact, this is a set of certain rules and ideas that we will always comply with. The second integral part of this engine, besides the analytical unit, which understands the configured parameters of the security policy, is the engine itself that constantly performs a risk assessment of the current access request or current transaction request. And this assessment, and this is a key idea to understand, is risk-oriented. It means that there is no such thing as if A, then B. Basically, there is a certain level of risk. This risk has limits. The risk is not a static parameter. It changes over time, even during a work session of the same user from the same device. And based on this risk, if the limits of the risk buffer are somehow violated, the engine must dynamically change its decision. And this is quite standard. The more dynamically the engine reacts to a change in the situation, such as, for example, the user is connected, everything is okay, but then unexpectedly the user begins to display system data in such volumes in which he has not previously displayed it before. So there is a certain behavioral anomaly, and accordingly the engine should identify the situation and respond as quickly as possible. The potential damage from an informational leak directly depends on the speed of the engine response. Next slide. At the bottom you can see a kind of a storyboard. At the left here there are signals, a set of all signals that we get. These are data from authentication providers, from directory services, from a database related to managing changes in the CMDB infrastructure, from configuration databases, etc. These are data on users, on devices, which is the operating system they're using, whether this system is registered in the domain or not, whether this system is registered in the MDM or EMM, Enterprise Mobility Management, as people now prefer to call it. In the meantime, it is obvious that in addition to your own data, there are also industrial data or cyber intelligence data, also known as threat intelligence feeds. It is clear that the engine must be able to receive data not only within your information perimeter, but also from the outside. And the more useful signals the engine can get from free or commercial feeds, from your partners, from other companies in the industry, in the region, and so on, the more informed will be its decisions on whether to grant access or not. The third functionality that our security policy engine must be able to implement is a dynamic request to increase the level of trust of a given user or device if access is denied. Let me explain. If a user connects from somewhere through an anonymizing proxy, through Tor browser, whatever, if there is any sign that we cannot trust this operation, or a user connects from a device that is not under control, or the latest security update is not installed on the device, then the engine must provide such user with the possibility to access those infrastructure elements that are responsible for updating and fix configuration errors that could potentially pose a risk. You need to automate this process as much as possible so that for users it will look like they're redirected between different pages of the information system in the browser. And after these issues are resolved, such user will finally get access to the corporate mailbox or, for example, to a corporate repository of the document library. This is also very important, because the most important objective is, after all, to provide access to the data, but make it as secure as possible, according to the adopted security policy. At the right, respectively, this is what we have to do with so the engine made the decision that we spoke of, based on the signals that our information systems provided, including some third-party feeds on what is happening in the world and in the industry. This also includes compromise indicators, different IOCs, etc. With regard to enforcement, here this functionality is already implemented on the part of applications or information assets themselves. It is very important to understand that Zero Trust models should include and cover all types of applications, even legacy applications that do not understand anything at all, except for simple HTTP authentications and passwords over the network without encryption, even without hashing it, etc. Even these kinds of applications must be included in the circuit, and the decision to give or prohibit access to the data of such systems must be made through our engine anyways. As for modern applications that support cutting-edge development standards, in particular authentication and data protection protocols, these are, of course, most easily integrated with the Zero Trust model engine. I will not even list them all. I think you all know them. Here, I will expressly note that such modern applications must not necessarily include applications created by some large cloud providers. These can be applications developed by you or developed for you by some contractor, but which support modern protocols, for example, SAML or OpenID Connect. Another very important thing, please do not forget that access to infrastructure or network elements must also be under control. For example, access to the administration panel, which is given to administrative personnel, also has to be included in the system. Naturally, the compromise of such an account or session will potentially cause maximum damage to the organization. It means that the system must not only include the infrastructure assets themselves, not only the DBMS in various infrastructure systems and various applications, but also the entire infrastructure that is responsible for control, monitoring, and management. People often forget about that. This is why I decided to talk about it afterwards. Keep in mind that sometimes access is required for a specific unstructured data object. It can imply some Microsoft Office or PDF or AutoCAD document. It doesn't matter, maybe some kind of 3D engineering drawing. Anyways, it is necessary to evaluate this transaction based on the risk profile, run it through our Zero Trust model engine, and make an informed decision in accordance with the security policy based on those risk signals that we have collected and identified. This is also very, very important. I mean that even access to a specific document like doc or PDF, downloading the latest price list, the last contract, a contract with prices and so on and so forth, all of it must also be run through this model. Now that we have analyzed the conceptual architecture, let's switch from thinking about spherical cows in a vacuum to thinking about a specific implementation. I will tell you about how this is implemented by Microsoft based on the solutions that Microsoft presents, because this is what I know best. Let's take a look. The first aspect is the signals that we receive from the user as the subject of access control. Here we basically get all the attributes and services of the Active Directory and the cloud data collected by Azure Active Directory. This also includes various systems such as Azure Multi-Factor Authentication, which allow us to provide multi-factor authentication not only by password and not so much by password. Probably the most modern method of authentication now is soft tokens, meaning confirmation through a mobile application. The only thing needed is having internet access. It does not require the transfer of an access code via SMS, phone calls, etc., because these channels are already recognized as insufficiently secure. Remember that the best way is with a soft token via a mobile app on a mobile device. This also includes quite specific systems that are responsible for behavioral analysis and identifying abnormal patterns in user behavior. This also includes systems that allow, well, I will not enumerate everything now because it is not my goal to tell you about the entire Microsoft portfolio. I just want to show you the degree of coverage that those classes of solutions that should be present, they are in general present in such systems. This should also include the system that allows, in a more or less real time, to assess the level of risk associated with the use of the account and the verifier of a particular user. For example, the system collects databases, sets of leaked hashes and passwords from all over the internet, including from darknet uploads if a user has gone through or is trying to go through the identification procedure with a password hash that has been leaked. I shall note that the system does not know the password itself. It only knows the final result of the password after performing the hash function. This, in general, is enough to clearly define that this account, or rather its password, has been compromised. Accordingly, we cannot trust the subject right now, and our system must require the user to go through either an additional authentication procedure using an additional method that do not have anything to do with the password, for example, MFA, or by using a device, or the user can be denied access from an unmanaged, uncontrolled device, but such user will be able to access the system from the work laptop, using which the password can be reset. What I want to say is that having determined all this, the system should automatically inform the user on what is really happening. It shouldn't just show the user HTTP error, access is denied, etc. Users should get clear information on why they cannot get access to the information system now and what specific steps they should take. Users can just click on, yes, sure, I want to change my password. Accordingly, they go to the portal where they can easily change it themselves. After that, they will be redirected back to the information system that they originally requested and will be able to continue performing their duties. This also includes all signals that we receive based on the attributes of the functioning of the device with which the user works. This includes all systems for managing device configuration, such as Configuration Manager, MDM systems, EMM systems, and not only Microsoft Intune, but also third-party partner solutions and Defender too. All these systems allow to collect the most complete information on what is happening on the device, and the health of the device is one of the key parameters for the effective functioning of the zero-trust model, because it is not enough for the user to be trusted. If a user account is trusted, but the user works on a compromised devices that is infected with malware, it is practically the same as if the user account was compromised. Okay, moving on. On the side of the applications and information assets themselves is something that we have already discussed, aspects that relate to the enforcement procedure or compulsory compliance with the organization's security policy. Here everything is also completely covered. These are not just Microsoft Cloud services, but also solutions from other cloud providers, some third-party software as a service solutions, support for various self-developed applications, which even if your application has not moved to the cloud, but it's still on-prem in your data center, even if it is based on some obsolete standards, does not support SAML, claim-based authentication, FIDO, and so on and so forth, you still need to include it in your system. And in order to do this, there are appropriate solutions such as, for example, Azure AD Application Proxy. This aspect of the system also includes controls over the configuration and infrastructure elements, which is known as Azure Resource Manager. I will not enumerate everything. I will try to focus instead on the most interesting and little known. I have already mentioned that access to unstructured data should also be controlled and run through this engine. So here we can control access to the level of a specific document which is located either on-prem or in a cloud storage. For example, let's say that this is a PDF document. Accordingly, it is assigned a certain category, a level of business criticality. It must be secured in accordance with this category, and users can be dynamically granted a minimum set of privileges to work with this document. For example, they cannot edit or delete some part of this document. And the most exciting part is that you can provide access to one PDF file to several contractors, partners, or subcontractors, but at the same time, each of them will only see numbers, cost, money, and monetary amounts related only to this particular partner or contractor. Only the first contractor will see the numbers A, the contractor B will see other numbers, while an employee of your organization will see all the numbers. At the same time, all this data will be protected not only at the level of a standard type of Microsoft Office application, but also thanks to a multi-layer encryption of the document. Moving on, what will the access control procedure look like now? Before, it was a static procedure. Now, we're looking at a typical request for access to information system data. Let me explain. We have collected all the attributes of various databases, and based on these attributes, our engine can build a certain risk profile. It is not a profile of a given user and a given device, but a profile of a given access request associated with a specific user and a specific device. To simplify, we have three risk profiles: low, medium, and high. Accordingly, depending on the change in the parameters, even after the workflow has started, the device health parameter has changed, which is very important. Please see the slide. In this case, the engine must, of course, dynamically increase the risk profile of a given request, a given working session, and as soon as the profile reaches the maximum score, the highest risk level, then this session shall be forcibly terminated and the user is redirected to the information system that will allow him to correct the health issues of this particular device. Only after that, the user will be able to request access again. The entire identity check will be performed again. The current risk profile associated with the transaction request will be calculated again, and only after that, if the risk profile complies with the specific security policy rule uploaded into our engine, only after that the user will have access to the information system again. This is what dynamic conditional access refers to. Now to wrap up. How does Microsoft implement this model? Let's see. Initially, we do not require device registration for work. Initially, it is somewhere in the vacuum. So single sign-on to facilitate things for user is partially implemented. In this case, the user enters trusted data only once and gains transparent access to a variety of information systems. Typically, a user-name-password combination is used for authentication. To tell you the truth, this has long been considered unsafe. This has not been enough for a long time, and if your authentication process only uses a username and password, you have to implement urgent changes. Let's continue. Over a period of time, Microsoft has implemented a number of actions which led firstly to the use of modern authentication protocols, the use of several factors needed to pass the authentication procedure, and the practical implementation of the least privilege level principle. This also includes JIT and GIA implementation, both for administrators and owners of information systems. The next aspect is the implementation of certain measures to control the health of the device, including control over the booting of the device. If we're talking about bootkit, rootkit, it doesn't matter what happens after the booting, what antivirus application you launch after the operating system starts to function. If the boot procedure was compromised, this device, of course, cannot be trusted. The zero-trust model implemented in Microsoft allows to even analyze this procedure. Even before the operating system has been loaded, a certain imprint is already being taken, and these data on what happened before the operating system was loaded is taken into account when building health profile of the device. The final stage is the most difficult. It implies the introduction of some kind of automated logic into the applications and the information systems themselves. It means that there is not only just a statistical role model with a certain set of powers defined for each role, etc. In this case, the system can dynamically calculate its own health. It implies a certain service or some application to which the user connects. It calculates the current health level by itself, and all decisions are dynamically recalculated depending on changes in this level of health of a particular service. This is the most difficult thing to implement because it implies developing some kind of logic for assessing health at the application level, which is considered health, etc. Well, this is where we are all heading anyways. Next slide. This is probably the simplest and the most illustrative example of how Microsoft's network infrastructure has changed. What we're seeing right now is the so-called flat network infrastructure. It is flat not because its address space is flat, but because there are no sliced segments of various types of resources, resource criticality levels, etc. Accordingly, there is a corporate network, the internet, cloud services, and users connect here and there. We also divide the concept of a trusted device into various categories. Moreover, the concept of the device itself, in essence, the device as a subject of access control, is categorized as registered, managed, fully managed, managed on-prem, managed in the cloud, what operating system is used, and so on and so forth. Depending on the level of control, the level of trust changes too. And depending on the level of trust, the device is granted access either only to a particular segment, for example, of the wireless network, which provides access to the internet. Through this wireless segment, the user will be able to connect to cloud services and continue their work. But if users need access to the corporate segment, they will have to undergo additional verification. The most of the applications were migrated to the cloud in order to remove the vast majority of users from the corporate segment, so that, as a general rule, their devices would not connect there at all. Naturally, a VPN was used for legacy systems that do not allow for any other type of connection. At the same time, historically, the share of VPN connection has been steadily decreasing. Our North Star objective is to completely eliminate virtual private network connections. And the final element of the system was categorizing particular infrastructure resources or sets of information assets depending on the time and level of their criticality. This process is known to many as microsegmentation or dynamic segmentation. A separate system segment is then allocated to such particular resource, and access to this segment is controlled separately by a separate set of network access policy rules, separate firewall rules, etc. Well, I have pretty much given you the essence of this. Now, to sum up, how do you start your journey? Let's say you saw how Microsoft does it. Obviously, the concept is not as simple as it might seem at first glance. I mean, it's easy to talk about it, but the real question is how to implement it. To help you with this, Microsoft has developed a so-called Zero Trust Maturity Model. This maturity model consists of 3 stages. The first stage is the traditional system, to which the majority of companies that do more or less well in terms of information security system implementation belong. Accordingly, there is basic SSO, there is an on-prem directory service. Unfortunately, I cannot enumerate every feature now. The second stage is already kind of an advanced level. Here we can already see hybrid identities, authentication provider both on-prem and in the cloud, the use of some kind of identity bridge between the directory service on-prem and the authentication provider in the cloud. And this provider doesn't have to be only Microsoft. There are also third-party partner providers. Generally, this is it in device registration, advanced application control options on mobile devices, even if the device itself is not registered in the MDM system. And the coolest stage is the optimal one. At this stage, everything should be already implemented during the previous stages. During the last stage, some new models of machine learning are being enabled, of course, the degree of automation is increasing, etc. The system basically heals itself. Operators and SecOps employees only monitor everything and sometimes fine-tune something to increase efficiency. At the same time, the model, of course, includes all 6 logic elements of the builder that we have analyzed. These are identification data, device and application data. All of them are described at each of the levels. Here is the document, to which I will definitely give you a link. I highly recommend you to read it. Well, that's not all of it yet. You would like to get an immediate understanding of where you are now. You already understand this model, but how to understand where you are now specifically and what exactly needs to be done right now. For this, we have a so-called wizard. You go to a web page, each answer a series of questions. There is absolutely no need to disclose any sensitive data. All data are quite high level. Afterwards, you get a certain document in which your current level will be identified for each of the elements, identification data, devices, etc. And most importantly, after that, you will get a list of recommended actions for each of these elements with a link to specific instructions on what exactly you can do and how to get started right now. Unfortunately, the topic of zero trust is quite big, and today I just wanted to introduce you to it. This is by no means a training on how to become a zero trust guru. To dive deeper into this topic, you can use a number of resources, as you can see on the slide right now. The main portal from which you can access all the resources on the slide, you can open right now by using the QR code in the upper right corner. That's all for me. I hope that this information was useful to you. I would like to conclude with a quote by Satya Nadella, which I think is quite revealing. He said that cybersecurity is like going to the gym. You can't get better by watching others. You've got to go there every day and do all the exercises yourself. I mean, that listening to me about zero trust, just listening and not taking any action, will probably not give you much edge. Thank you again for your attention. Don't forget that security starts in our own heads.